In problems that ask you to find the area enclosed by some curves, probably the best thing to do is to draw them if you can. Now in this problem, they've actually tried to disguise the identities of the curves by getting the variables on one side and a constant over on the other. So what we could do is take these and rewrite them in a way that's more familiar. Let's see, if I get y alone, I get y on one side and 3x squared minus 4 on the other. Now I can recognize the curves and draw a little sketch to help me out. X cubed I know goes like this. And then if you had 3x squared, that would be the parabola opening up but shifted down 4. So, okay. Now, so I can see they're talking about the area between two curves. If I consider most of the regions, the area is infinite. For example, over here, there's infinite area, and down out here, there's infinite area, and even here, there'd be infinite area, and here. So the only one that's finite would be this region here. So I think what we need to do is to integrate from whatever this point is to whatever that point is, the integral from a to b. We'll just take, if we want to find the area, imagine a little piece of area here. It's like a rectangle, right? Its width is the change in x, and its height is the upper curve minus the lower curve. From our sketch, we can tell that the curve that's up above is x cubed, and the curve that's down below is 3x squared minus 4. So that's the integral we need to do, but my question right now is, what are these values? In order to solve that, we need to figure out where the curves cross. Of course, we're looking for the x value where the two curves cross. If at that place where they cross, for that same x value, the two y values are the same. So what we can do is say, well, at that x value, x cubed and 3x squared minus 4, those are the two y values. They would have to be equal. So x cubed equals 3x squared minus 4. So x cubed minus 3x squared plus 4 is equal to 0. Now we have a polynomial equation. Now this is the kind of thing that you probably studied in a pre-calculus class, factoring a polynomial, especially when it's cubic. What you're hoping for is to find, if you could find, say, a solution of this equation, then that would also tell you a factor of this equation, and so once you know a factor, you could divide to figure out what the remaining part is, and then factor that, and so on. So there was a rule in pre-calculus that was called the rational zeros theorem. Basically, you look at the factors of the constant term, which in this case the constant's 4, so its factors are 1, 2, and 4, and the factors of the leading coefficient, in this case the leading coefficient is 1, so that's its only factor. And just think about plus or minus taking a factor of the numerator over a factor of the denominator. In this case, it gives us 6 possibilities, plus or minus 1, plus or minus 2, and plus or minus 4. I can just plug those into this function, and if I get 0, then that's going to be one of the roots, so I could check them that way. Let me try 1. If you try 1 in this function, you get 1 minus 3, that's negative 2 plus 4, so that's 2. That didn't work. So plus 1 is not one of the zeros. I could try a negative 1. In this case, I get negative 1, and negative 1 squared is 1, so I get negative 1 minus 3. That's negative 4 plus 4 is 0. So from that list of possible rational zeros, which come from factors of the constant over factors of the leading coefficient, I have actually found that x equals negative 1 is one of the solutions. That would mean x plus 1 is one of the factors, right? So if I write it this way, x equal negative 1 being a solution is because x plus 1 would have to be one of the factors. That's called the factor theorem. Now what I can do, since I know that's got to be a factor, is I can actually use long division to factor this. I know that x plus 1 has got to go in there evenly because negative 1 was one of the zeros, and so x plus 1 has to be one of the factors. So with long division, I look at the leading coefficient here and the leading coefficient there and decide what times the leading coefficient would equal that leading coefficient, which in this case that's x squared. Now, once I've chosen a number, I do the multiplication. So x squared, and then x squared times 1 would be plus another x squared. After you multiply, just like with regular division, you subtract. X cubed minus x cubed is nothing. Negative 3x squared minus another x squared would be negative x to the negative 4x squared. And 4 minus nothing would be plus 4. Now we can ask, well, what times x would give me negative 4x squared, which negative 4x times x would be negative 4x squared. So if I actually multiply to get negative 4x squared minus 4x, let me subtract again. Negative 4x squared minus 4x squared would be 0. And nothing minus 4x would be plus 4x. And 4 minus nothing would be 4. Now what times x gives 4x? Well, 4 does. So we have 4x plus 4. And when we subtract that whole thing, we can see they're the same, so the remainder will be 0. Okay, so what we found is that our equation here actually factors to x plus 1 times x squared minus 4x plus 4. And this is quadratic, so it's easy to factor, and even if I couldn't factor it using nice integers, I could use the quadratic formula to solve that. So I have basically x plus 1. This does factor to x minus 2 times x minus 2. And so we see that x equals negative 1 and x equal 2 are the two solutions. Now negative 1, that must be this value here, and the 2 must be that value over there. So I know that the integral I need to do is the integral from negative 1 to 2, taking the curve that's up above minus the curve that's down below. If I distribute my negative, this is what I have. So from the fundamental theorem, this is a nice continuous polynomial, so I can find its antiderivative. See, that would be minus x cubed and then plus 4x. And evaluate that antiderivative between my two bounds, negative 1 and 2. If I plug in 2, I have 2 to the 4th, that's 16. 16 divided by 4 would be 4. 2 cubed is 8, so we have minus 8, and 2 times 4 would be plus 8. So there's the value when you plug in 2. When you plug in negative 1, you get negative 1 to the 4th is still 1, so we get 1/4. And negative 1 cubed would be negative 1 with another negative, makes plus 1. And 4 times negative 1 would be negative 4. And I just need to subtract those two. Let's see. First off, negative 8 and 8 make 0, so really all I have is 4 minus 1/4 minus 1 plus 4, since negative 4 would be plus 4. So we have 8 minus 1, that's 7 minus 1/4, and 7 minus 1/4 would be 6 3/4 for the area in this region.